Welcome back. I am a PhD measurement scientist with expertise in making measurements outside the lab. And that involves trying to take instruments that are typically found in the lab and help build them to be more robust for environmental settings. So a couple days ago, I took a small Raspberry Pi outside into a park nearby and decided to measure the UV light, the volatile organic compounds, and track my location using a GPS sensor. Now that entire project is on my Analytic Code project channel. On this channel, I'm going to focus on how I actually built the code to measure the UV light, but also the visible light and IR light. But the larger focus is going to be understanding my home environment, how much light is getting in, what type of compounds am I exposed to using my VOC sensor, and other techniques that I'm going to be combining over there on my project channel. But again, I'll show you how I code all that on this channel. So let's get started. So most times on the channel, I am using a .ipynb file. That is an interactive Python notebook commonly associated with the Jupyter project. But in this case, I'm going to use a .py file, a traditional .python file. And that's because I want to be able to call this module into a larger program that I'm going to use to record the light. So here I'm going to import time, board, BUSIO, as well as the Adafruit LTR390, the Adafruit TS-L2591. And like any other project, we need to import these libraries so we have access to all the code handles that are going to be used to operate the sensor. I'm also going to use this I2C setup. So I'm going to instantiate the board, essentially turn on my I2C connectors, as well as initializing my sensors, in which case there are two on the particular chip that I'm using. One that will focus on the UV light and another that helps more with the visible light and IR light. In this case, I'm going to instantiate by setting my gain to low. That way I don't overwhelm the sensor. This is definitely a variable you want to play with. And all of this here is part of setting up the chip, and it's fairly straightforward once you read the documentation. Now, when I was doing some testing, I created this print statement so that I can read the output of my sensor. And essentially with this while true statement, I'm showing try to read the light. So in this case, I'm going to read the ambient underscore raw, which is this LTR.light, as well as the raw UV light, the UV index, both from the LTR sensor, and then my visible light, which would be from this TSL2591, where we have LUX, which is the human perceived brightness, the visible light, which is just a raw digital signal between, I believe, 0 and I think 200,000. And then we have our IR and our full spectrum light, which is just a combination of our raw, visible, and IR light. Next, when I'm testing this, I was printing this to the screen, but rather than show you this, I want to demonstrate how this is actually wrapped into my home testing project. So now I'm showing you my environmental sensors version 2 updated Python file. And what you can see, I'm calling in these same sensors, and I'm going to use a series of additional functions like this getUV, which is just going to call the UV underscore raw and the UV underscore index data. And the goal is to combine this data with my location data, as well as my VOC data, to get a full picture of the environment that I have in my home. So let's look at this in the real world. The goal, like I said before, is to understand the environment of my home. If you look at this data now in the home context, we can see that from the time I'm recording, which is about 11:45, the light is off. And if I run this again to get the most recent time, it is completely dark. So I am reading my visible light intensity. This is that digital signal. I'm looking at the LUX value as well as my IR light. Now the IR light could be from the sunlight, could be from other heat sources, either directly or indirectly. And as you can see, all these signals are quite correlated. And in previous videos, we've gone over some signal processing code. So this certainly could benefit from some smoothing, or we could compute a rolling average. If you want to see that, that would be done on this channel, but then apply to the project channel. And so what I'm going to go do is turn the light on, wait a couple minutes, and then update this data file. So in another video, I'll demonstrate how I'm using this pool files from Living Room to get the updated data. But in this case, let me go turn the lights on, wait a couple minutes, and then let's see the spike in this table. I've just turned the lights on, and this device runs every minute. So let's wait a couple minutes for the new signal to come through, and then I'll update this data file and see how the figures are updated. Okay. So it's been a few minutes and we can now see that there is a small signal here where the light was turned on. And this highlights the amazingness of these sensors. We're able to collect a lot of data. In this case, I'm just showing the light sensor, but there's also VOC measurements that I have, temperature measurements, humidity measurements. And if you want to follow that, subscribe to the Analytical Tutorials channel that you're on now, and subscribe to Analytical Project channel to follow this project and many others. In any case, I'll see you in the next video. Peace.